Hello and welcome back. In this video we will be doing our last lesson for the semester on complex numbers, if I can spell it right. So the first thing to notice is that there's in fact no number whose square is equal to -1. If you take a number and you square it, if your number was positive, a positive number times a positive number is positive, which can't be equal to -1. If you take a negative number, and you take a negative number times itself, you get a positive number because the negative signs cancel out. And again, you can't get -1. The only number that's not positive or negative is 0, and 0 times 0 is 0. And again, you can't get -1. So no matter what you do, you can't take a number and square it to get -1. But it would be useful to have such a number. For instance, if I wanted to solve this equation, I would need to find a number that I could plug in for x to give this. So what we do is we sort of invent one. We have the number that we call I. And this number is, just like any other number. We can add it and multiply it and do whatever. And it just is this sort of imaginary number that solves this equation. So for example, if I take I and square it, I get -1. But if I take I and cube it, we should also be able to figure out exactly what this is. So I cubed is going to be I times I, which if I take I times I know that I get -1. So this is going to be -1 times I, and -1 times I, that's just going to be -I. -1 times anything just adds a negative sign to it. If I take I to the 4th power, it's going to be I times I times I times I. So for instance, I could take the first two i's and multiply them together to get -1, and then I could take the last two i's together and multiply those together, so I get -1 there as well. So now I have -1 times -1, which is 1. So I is going to be a pretty useful construction for us. And essentially what we'll see in the next video is that that numbers involving I can be written as vectors, and therefore some trigonometry comes into play. But for the moment, I just want to work with I and see exactly what's going on here. So again, I is a number and can be added to or multiplied by any other number. So I could take 2 times I, whereas 2I, or 5 plus I. I could take 6 minus 3 times I, or the square root of 2 plus I times the square root of 2. What you'll notice is that typically, if it's an integer, we write it in front, so we'll write 2 times I. But if I have the square root of a number, I normally write it at the back of the I, because if I write the square root of 2I, it almost looks like it's the square root of 2I, and it's hard to tell where the square root sign stops. Does it stop after the 2 or after the I? So it's just convention that I follow to put the I in front of the square root sign rather than the back. It doesn't really matter. So these numbers are what we call complex numbers. Real numbers are what we're used to. A real number is a number that is going to be an integer like 2 or 3 or -17, or it could be square roots of these guys, so the square root of 2, the square root of square root of 17, these sorts of things. What we call complex numbers are all combinations of real numbers and the imaginary number I. So for instance, this is a complex number, this is a complex number, this is a complex number, this is a complex number. I by itself is a complex number. All real numbers are included in the set of all complex numbers. So any real number is also a complex number. It's just not very complex. And we give names to parts of these guys as well. So here, if we have a number, a complex number, that is a plus bi, we call a the real part, and the bi is called the imaginary part. And there is some notation for this. I don't think the book uses this very much, but if I'm given x and I want the real part, we write rex, and that's a, and then the imaginary part of x is going to be just the bi. So, but we won't really see this. This is just kind of useful to mention. So I think the thing that what I really want to do is sort of practice working with I. So it's just going through and making sure that we understand, exactly what's happening. So for instance, here I've got the square root of negative 100, and we can see that this is going to be equal to the square root of. Need to write this a little bit better. The square root of negative 1 times 100. So we can start pulling things apart. And this will be the square root of negative 1 times the square root of 100. And the square root of negative 1 is going to be I, and the square root of 100 is 10, so I might write this as 10i. And that's it. So the square root of negative 100, we can just split out that negative 1 and treat it separately. Here I've got the square root of negative 4 times the square root of negative 4, so we'll just do this for both of these guys. This is going to be the square root of negative 1 times 4, times the square root of negative 1 times 4. And just like we saw before, I can take the square root of negative 1 and call that I. And then the square root of 4 is going to be 2. And then this guy, I've got the square root of negative 1, which is I, times the square root of 4, which is 2. And now we just have to multiply these guys. So it's I times 2 times I times 2. And again, we can multiply these in any order that we want. So maybe I'll go 2 times I times I. And as I simplify this, 2 times 2 is 4. 4. And I times I is negative 1. So we get negative 4. And that kind of makes sense. The square root of negative 4 times the square root of negative 4. Well, the way square roots work is that if I take the square root of a number times the square root of itself times the square root of that same number, I should just get that number. The square root of 2 times the square root of 2 is 2. So the square root of negative 4 times the square root of negative 4 should be negative 4. We've got to be a bit careful though. Here I've got the square root of negative 4 times negative 4. But this is underneath the square root sign. So this is the same thing. What is negative 4 times negative 4? That's 16. Because the negative signs cancel out. And the square root of 16 is 4. So this is just a word of caution that you have to simplify things underneath the square root before you start taking the square roots. Up here, the negative 4s were in different square root signs. Here, they were under the same sign, so we just get 4. And then lastly, we might have to simplify some things as well. So for instance, if we have the square root of negative 50, this is going to be the square root of negative 1 times 50. So the square root of negative 1 is I, and then we're going to take this times the square root of 50. But 50 can be simplified a bit. 50 is also, for instance, 25 times 2. The square root of 25 is 5. But the square root of 2 is, well, we can't simplify that. So this is going to be I times 5 square root of 2. And we can't really simplify this anymore. The square root of 2 can't be simplified. So that's, this is just some examples of taking square roots. Not only can we take square roots of numbers, but we can also add numbers, add complex numbers, subtract complex numbers, multiply complex numbers. And this works exactly the same in this as it would in any sort of algebra class. We're just going to combine like terms. So I'm taking 1 plus 2i plus 3 plus 4i. So let's combine like terms. Well, what are our like terms? I've got a 1 and a 3, and those are just numbers. We can add those together. And then I've got 2i and I've got 4i. And these guys are going to be complex numbers. So let's start adding these up. So 1 plus 3 is going to be 4. Okay, that's straightforward. 2i plus 4i. Well, if I have 2 i's plus 4 i's, that's going to be 6 i's. And the 4 does not have an imaginary number attached to it. The 6 does. So these are distinct terms. These we can't add those together. This is as simple as we can make this. So that's all the way down to the simplest forms. So here I've got 10 minus 6i minus 1 plus I. So here we want to be a little bit careful because we're subtracting. So we just have to pay attention to the negative signs. So over here I've got a 10. Here I'm subtracting 1. So when I want to write this term down, I distribute. So I'll take minus 1. Over here I've got minus 6i. And then for the last term here, I'm subtracting I. That sign distributes. So I'm subtracting I. 10 minus 1 is 9. And negative 6i minus I. Well, I've got negative 6 of these, and I'm subtracting 1 more, so that's going to be minus 7i. And then the last difference down here, I've got 3 plus 7i minus 4 minus 3i. So I've got 3, and I'm going to subtract 4. So these are all my terms without i's. And then I've got plus 7i. And then I'm subtracting a negative 3i. Well, if you subtract a negative, it's the same thing as adding a positive, since the two negative signs will cancel out. So this is going to be adding 3i. So 3 minus 4 is negative 1. 7i plus 3i is 10i. And there you go. For multiplying, again, we do the same thing like we normally would. And I think my favorite method for multiplying things where I've got two things added together is to FOIL. So let's do this. So we'll take our first terms, so the f in FOIL. So 1 times 3. So 1 times 3 is going to be 3. And then we need to take our outside terms. So 1 times 4i. So plus, and I'll just write this out. 1 times 4i. And then we take our inner two terms. So this is going to be 2i times 3. Plus, and then our last two terms, 2i times 4i. And now we get to start simplifying. So we've distributed all of our things. So the 1 times the 3 is just the 3. 1 times 4i, well, 1 times anything is just that thing. So this is just going to be 4i. 2 times I times 3, that's 6i. And here, I've got 2 times I times 4 times I. Well, the 2 and the 4, so 2 times 4, and that's just going to be 8. And I times I, that's negative 1. So again, I've just combined everything in here. So then I've got 3, and this is going to be a negative 8, right? Because 8 times negative 1, that's going to be negative 8. So 3 and negative 8 is going to be negative 5. And then I've got 4i plus 6i is 10i. Cool. And let's do one more. We've got 3 minus 7i times 6 plus I. So again, we will go through this. So we'll take the first terms, 3 times 6. We'll take the outer terms, 3 times I, plus negative 7 times 6, plus negative 7 times I. So again, here I've got 3 times 6 is 18. 3 times I is 3i. Here I've got a negative sign. Then 7 times 6 times I. Well, that negative sign, I'll subtract this instead. 7 times 6 is 42 times I. And then here I've got negative 7 times I times I. Well, that negative sign, I'm going to subtract this. So it's going to be negative 7, and then I times I is going to be negative 1. This is what's special about I. And by simplifying this, I've got 18 plus 7. The two negative signs cancel out. and then I'll have minus 39i after I combine these.